Okay, let's unpack this. Today we're diving deep into Amazon VPC. Our mission is to, cut through the jargon, really understand what Amazon VPC is, why it's not just useful, but actually pretty crucial for building secure, scalable stuff in the cloud, and how its key components work together. For you, our listener, think of this as maybe a shortcut, a way to grasp how you can carve out your own private, secure space in that huge, shared AWS cloud.
Right. Amazon VPC, virtual private cloud. It's basically a service that gives you your very own isolated network right there inside AWS. This private space is where you deploy and run your resources, your EC2 instances, databases, applications, you name it. The real power here is you get complete control. You define the whole network environment, IPs, subnets, routing, and yeah, critically, the security.
That's a great analogy, like renting your own private office building, but inside this massive complex, which is AWS itself. And you get to decide the layout, who gets in the door, how it connects outside, all while keeping your stuff separate and safe from everyone else in the complex.
Exactly. And what's really neat is while it offers all this capability, it's a foundational service. The VPC itself, no extra cost. You just pay for the resources, the EC2 instances or databases you actually put inside it.
Okay, so you said crucial. Here's where it gets really interesting. Why is creating this private space so critical? What's the big deal for businesses and developers?
Well, it boils down to a few key things: security, control, scalability, connectivity, and increasingly, compliance. VPC isolates your resources from other AWS users, which is fundamental. It lets you deeply customize network settings, supports growing workloads easily, connects smoothly to other networks, even your on-premise data center, and helps meet those sometimes tricky regulatory requirements.
Can you give a concrete example? Like, where does this really shine?
Sure. Think about a web application. You probably have, say, web servers and a database holding sensitive customer info. With VPC, you'd typically put that database in a private subnet. That means zero direct internet access, really locked down. Meanwhile, your web servers, they can sit in a public subnet so people can reach your site. This separation, this design, builds security and compliance in from the start. It prevents a direct attack path to your most valuable data.
Okay, got it. So we have our private office building concept. Let's look under the hood now. How does this thing actually operate? What are the main structural components, the nuts and bolts?
Right. So a VPC always starts with a private IP address range, one that you define, like 10.0.0.016 or something similar. Then, within that big range, you divide it up into smaller segments called subnets. Think of these like different floors or departments in your building. And critically, each subnet lives within a specific availability zone, which gives you that built-in redundancy. Subnets can be either public, meaning they have a route to the internet, or private, meaning they're isolated.
Okay, subnets are like the floors. How do you control who gets in and out of these different rooms or floors? The security aspect.
Yeah, that's handled by two main things: security groups and network ACLs or NACLs. Think of them as your firewalls, but they operate at different levels. Security groups act like firewalls for your individual EC2 instances. They're stateful.
Stateful. What does that mean in practice?
It means if you allow traffic in on a certain port, the return traffic for that same connection is automatically allowed back out. You don't need a separate outbound rule for the reply. It remembers the connection state.
Okay, like a bouncer at a specific office door who remembers who they let in.
Exactly. Then you have NACLs. They operate at the subnet level. Think of them as the security desk for the entire floor. And these are stateless.
Stateless, so the opposite.
Precisely. It doesn't remember connections. You need explicit rules for both inbound traffic and outbound traffic. If you allow traffic in on port 80, you also need a rule to allow the return traffic back out on the appropriate ephemeral ports.
Got it. So 2 layers of security working differently. Instance level and subnet level.
You got it. Understanding that stateful versus stateless difference is really key for effective network security design in VPC.
So your resources are nicely isolated in their subnets, but they often need to talk to the outside world, right? For updates or just to serve web traffic. How does that happen?
Good point. For your public subnets to reach the internet, you attach an internet gateway to your VPC. Think of it as the main entrance and exit for your entire building, connecting directly to the public internet.
Okay, that covers public subnets. What of those private ones, like where the database lives? You said they're isolated, but what if they need outbound internet access, say, for software patches?
Right, you don't want to expose the database directly. That's where a NAT gateway comes in. Or a NAT instance, though gateways are generally preferred now. You place the NAT gateway in a public subnet. Your instances in the private subnet then route their internet-bound traffic through the NAT gateway. The NAT gateway uses its own public IP address to talk to the internet, gets the response, and sends it back to the private instance. So the private instance can initiate outbound connections, like downloading updates, but the internet can't initiate connections into the private instance. It's like a secure, outgoing-only mail service.
Makes sense. A secure way out, but no way in. Now, what if you have two of these VPCs, maybe different teams, different projects, or even different AWS accounts? How do they talk securely?
Yeah, that's a common scenario. The primary way is VPC peering. It lets you connect two VPCs directly using private IP addresses, as if they were on the same network. Traffic between them stays entirely within the AWS backbone. It doesn't go over the public internet. It's like building a secure private walkway between two office buildings.
Even across different AWS accounts or regions?
Yes, VPC peering supports cross-account and even inter-region connections now, which is really powerful for distributed systems.
That sounds incredibly flexible. But are there any catches or things to watch out for with peering, especially as networks get more complex?
Good question. The main thing to remember is that VPC peering is non-transitive.
Non-transitive.
Meaning, if VPC-A is peered with VPC-B and VPC-B is peered with VPC-C, VPC-A cannot automatically talk to VPC-C through VPC-B just because of the peering.
Ah, okay, so there's no automatic pass-through.
Exactly. You'd need a direct peering connection between A and C, or you might look at a different service like AWS Transit Gateway for more complex hub-and-spoke network designs where you want that kind of central routing. Planning your peering is important.
Okay, so VPC is this foundational network layer. How does it integrate with, the actual services people use every day on AWS?
It's fundamental to almost everything. Your EC2 instances. They launch into a subnet within your VPC, your RDS databases. You typically place them in private subnets for security, using the VPC's routing and security features. Elastic load balancers, ELBs. They need subnets to operate in, distributing traffic to your backend instances across potentially multiple availability zones, all within the VPC structure.
So it's really like the plot of land and the foundation for your house in the cloud.
That's a good way to think about it. The VPC is the land and foundation. Subnets are the rooms for different purposes: EC2 room, RDS room. The networking components like internet gateways and NAT gateways are the wiring and plumbing connecting it to the outside. And security groups and NACLs are your locks and security systems.
This deep dive really highlights the power you get with VPC. It's about creating that secure, tailored network environment.
Absolutely. It gives you that fine-grained control over your AWS resources, enabling you to build applications that are robust, that can scale, and that meet compliance needs. It's essential knowledge.
So here's something to think about. Given this incredible flexibility and control VPC offers, how might really understanding these core networking concepts let you move beyond just deploying applications? How could it empower you to truly reimagine how you architect solutions in the cloud, maybe pushing towards things like more advanced resilience patterns or even zero-trust security models?